whatever. We should.
From all you No, I should buy 10 Gucci belts for a bunch of people.
Say it's real.
No, well, yeah. So that like that one kid that wears his doesn't think it's special. Okay, look.
Do you not like designer items, Patch?
I don't really see.
This is designer version.
What?
I'm more about function.
Figure it out.
Sorry. Don't understand.
I apologize. Another problem with this is a personal preference thing.
I'm a compulsive buyer of all of this.
Did we get -8 for the first one and 1 for the second one? So on the first one, we just need to rewrite both sides with a base of 5. So I just need to change 25 to 5 squared. Let's set the exponents equal. Subtract 10, we get -8.
You know this thing.
What's that?
This is we did this before.
Yeah, it's a 1. That's why this is a 1.
So for the
On the second one, I needed to rewrite both sides with a base of 3. So I could rewrite 9 as 3 squared, 27 as 3 to the third. Then, since I'm raising a power to a power on both sides, I would need to multiply, which means I would distribute this 2, distribute this 3. When I set the exponents equal then, and solve, we should get a equals 1. Okay. So we good with solving exponential equations when we can get a common base on both sides? So today then, we're going to take a look at the situation where it's impossible to get a common base on both sides, right? Where we cannot rewrite both sides with the same base. So here are the steps that we're going to use to solve problems today. So write these down in your notes. And so we could actually use these steps even if it is possible to write both sides with a common base. Okay? So the first thing that we want to do, okay, and the ones that we're going to look at today, there's only going to be one exponential expression. It's going to be like an exponential that's equal to a number. So the first thing we want to do is isolate the exponential expression. Okay? We could be adding or subtracting something to it or multiplying it by something. But we need to move that value to the other side of the equation. Okay, then the key, right, to solve, we're going to rewrite the exponential expression into a log expression, that lazy 7 thing. Okay, we're going to use lazy 7 today. So if you want to make a note, step 2 means lazy 7. Okay, then we're going to talk about how to use the calculator to evaluate logs. So if you don't already have a calculator, grab one. There are a bunch in the bin over there. And then after we evaluate a log, we still may have a little bit of maybe adding something to both sides or dividing both sides of the equation by something to actually solve for the variable. Okay, and we're going to round to 4 decimal places for these. Okay, most of our answers are going to be long decimals, so we're going to round them to 4 decimal places. All right, give you another minute here to finish copying down those steps. All right, everybody got them copied down? All right, that was a minute. All right, so let's take a look at our first example. So if you look at your steps, the first step says to isolate the exponential expression. Okay, that means there could be something like multiplied over here or something added. There is not in this case, so step 1's already done. Step 2 then says to rewrite the exponential as a log. How do I do that? How do I do lazy 7 here? Yeah. So the base of the exponential becomes the base of the log. Right? Bless you. So this is going to be log base 2 of 61 equals x. So we actually already have x by itself. I can just plug this into the calculator now. So get a graphing calculator if you do not already have one. Yours will not do this.
Dispatch me on the back, please.
Okay, so on your graphing calculator, if you press the math button and then scroll all the way down to A, it says log base. So math, and then scroll all the way down to log base. Then you can input log base 2 of 61. Say it again for me.
5.93.
And so make sure that you feel comfortable inputting this into the calculator. Okay, make sure that you find where log base is and that you can put that in. Okay. Questions so far? Alright, then on the next one, similar situation, we already have the exponential by itself. And I'm not multiplying this exponential by anything. I'm not adding anything to the exponential. And by exponential, I mean the thing that has a variable in the exponent. Even though there is something being subtracted in the exponent, I'm not subtracting something from the exponential term itself. So we can jump right into lazy 7. So the base of the exponential becomes the base of the log. So I'll have log base 8 of 92 equals the exponent, m minus 7. So now I can put this log into the calculator.
2.1745.
745. Now we do have one more step on this problem to get m by itself. I would need to add this 7 over. So we would get 9.1745 for our value.
I was like, so it was 7.6927.
I have to carry. I don't want to do that. Alright. We okay with this? Not too bad, right? Alright. On the next one, we do actually have a value that I'm multiplying the exponential by. Right? So whenever I'm multiplying the exponential by something, I need to get rid of that first before I do lazy 7. Okay, so exactly. So the exponential is just this 7 to the end, just whatever thing has the exponent on it. So this 4 is not part of the exponential. So I need to divide both sides by 4 first. It's 148 divided by 4. 37.
Good job.
Thank you.
You flex on the star.
Now I've got the exponential by itself. Now I can use lazy 7. So we'll have log base 7 of 37 equals n. So what would we get here? Say it again. 1.6. You all right? All right. How about you guys see if you can try this one? Okay, on this one, again, we need to isolate the exponential. So I need to do something with this minus 5 first before I lazy 7. Okay, so take a minute here and see if you guys can try number 6.
You're still here.
get 1/2 or 0.5. Feeling good? Alright, flip over to the back. Let's take a look at this one here. On this one, there are actually two things I need to do before I can use lazy 7. Okay, so first, I've got 7 minus 4 to the x minus 1. I need to get rid of this 7. So since it's positive, I would want to subtract 7 from both sides. Okay, then I get negative 4 to the x minus 1 equals 11. Now, I still have this negative sign out front. I need to get rid of that somehow. How can I get rid of a negative sign? I can divide both sides by negative 1. We would think about this as the same as multiplying by negative 1. Right? So what I can do here is divide both sides by negative 1. So we get 4 to the x minus 1 equals negative 11. Now we have the exponential by itself. Now we can rewrite this as a log. So I would have log base 4 of negative 11 equals x minus 1. What's that? Yeah, why can't we put this in the calculator? Can't have a negative inside of a log. I'm not going to go through the whole explanation, but we just need to know that we can't have a negative inside of a log. Alright, so if you try to put this in the calculator, it just gives you an error, right? Because you're inputting a negative value. So, what that means is, there it is. No solution. You okay with that one? Alright. About something like this. You tell me, what do I need to do first here? Gotta fix that 10. How do I fix that 10? Divide both sides by 10, right? Because I'm multiplying, so to undo that, I would divide. So we get 5 to the 3k minus 3 power equals 4.
Why isn't it 5 with that?
Because you're just dividing 10. That's
You pretty much. Yeah. And that's what division is.
Right. Yeah. Now I can lazy 7, so what will that look like?
log base 5.
Base 5
4 power
of 4.
equals 3k minus
Or, now we can put log base 5 of 4 into the calculator.
0.8613.
8613. So we get 0.8613 equals 3k minus 3. Now I still have actually 2 steps to get k by itself. So first I would add 3 over. I would just get 3.8613. Then divide both sides by 3. Help me out on that. What do we get then? .2871. Alright, we feeling pretty good with these? why don't we, take a little chunk of time here, be 10 minutes or so, and you guys just try some of these. Right? Try as many as you can here, and say in the next like 10 or 12 minutes, and then we will go over them. All right, let's take a few minutes and take a look at a couple of these together now. So I put this one on the board. I think for number 9, we should get 4.0545. Yeah. Good with that one? All right, we had to subtract 15 and then divide by 4 before we could lazy 7. All right. On the next one, again, there were a couple of things we had to do to get the exponential by itself. So first we would subtract this 7 over. Negative 2 times 5 to the p equals negative 70. Divide both sides by negative 2. 5 to the p equals 35.
Does it matter if you subtract or add before you divide?
Well, kind of. Yeah. So what?
Because I was following like the division or you guys subtract.
Well, when we're undoing things, we actually want to use reverse
That
calculus.
would have been.
So we technically we could divide by negative 2 first, but if I were to do that, I would have to divide both of these things by negative
See, I
2.
didn't do that. Yeah. So all these wrong.
Yeah, so I mean that's you could do the negative 2, but then you have to divide that by negative 2 as well, and then subtract that over to the other side.
Well, at least I get there.
Yeah. So now here we can lazy 7. So I'll have log base 5 of 35 equals p. This we can just put in the calculator. So what is that?
Oh, p equals 2.2090.
2.2090.
Yeah.
You okay with that one? Alright. Similar situation here. We would subtract 1 from both sides to start. Then divide by 5 to get the exponential by itself. What's 180 divided by 5?
180 divided by 5 equals 35.
35? Yeah.
36.
36. Oh yeah, there's 36 something.
Now we can lazy 7. So log base 9 of 36 equals b minus 1. What's log base 9 of 36? What is it? 6311?
Oh, no.
Oh, 9. Yep, didn't get that at all. Heard 11, said 09. It's not even close. Then we have one more step. Add 1. So 2.6309. Questions? My question is, do you have a question?
Oh,
Did I get that?
no, I subtracted 1. So
No,
I-
instead of adding.
I did- oh.
All right, then on number 12, again, we've got a couple of operations to do first. So we'll add the 3 over. So 8 times 11 to the 7k equals 216. Divide both sides by 8. We get 11 7k equals 216 divided by 8. 27. Now I can rewrite it as a log. So log base 11 of 27 equals 7k. What's log base 11 of 27?
All of this one.
Then to get k by itself, divide both sides by 7. What do we get there?
0.1963.
1963. Any questions on this stuff? I think that's about all we have time for today.
On the other one.
Doing what?
The last one, subtracted one. This one, I even put the add 3 and subtracted 3. Did all this on 2.
I see.
180.